Welcome back, everyone. Now, in this lesson, we're going to be talking about actually evaluating series, and we're going to find either the partial sum or we're going to find the infinite sum, depending on whatever series we're working with. Now, in order to evaluate these sums, we're going to be using these 4 boxes right here, and we're going to be referencing these 4 areas a lot. So we're just going to kind of dive right in. So looking at the very first one, so we want to evaluate the series from the first term to the 10th term using this rule over here. Now, notice how the rule is written in kind of the form of y equals mx plus b. So what's going to happen is we're going to actually use one of these 2 formulas here. Now, I personally like to use this top formula, but there are going to be cases where you're going to need to use this bottom formula. So notice how this top formula, we need to know the value of the last term, whereas down here, we don't have to know the value of the last term of the series, or the sequence rather. So in this case, depending on what information is given to us, we may actually need to use this bottom equation. I will say this bottom equation is especially used a lot in applications. So I'm going to use the top equation for right now, and then I'll use the bottom equation on another problem. So starting off, we're going to find the partial sum, and it's going to be the number of terms divided by 2, the value of the first term, plus the value of the last term. So in this case, because we're starting at the first term and going to the 10th term, what that tells us is that right here, the first term is going to be the first term of the sequence, and then a sub n is going to be the 10th term of the sequence. And then your n value is going to be the number of terms. So for the number of terms, your n value, if you remember, I like to do the top number minus the bottom number plus 1, which in this case, it's just going to give you 10. So if you start at 1, and then you end at a specific number, this specific number up here is your n value. But remember, we're not always going to start at 1. So when I plug in, I need to find the values of my first and 10th term. So a sub 1 is going to be equal to 15 minus 3 times 1, which is going to be 15 minus 3, which is equal to 12. And then a sub 10 is going to be 15 minus 3 times 10, so 15 minus 30, which is negative 15. So when I plug in, so my partial sum is going to be for 10 terms, so I'll do 10 divided by 2, which is going to be 12 plus negative 15. So when I find this value, this is going to be 5 parentheses 12 minus 15, which is going to be a negative 3, which means this partial sum is going to be equal to negative 15. So moving on, looking at the next one, now your equation is written in the form of your geometric sequence. So in a geometric sequence, what you hopefully remember is that the number here in the front is the value of your first term, and then your value inside is your common ratio. So with this formula, we're going to be using the finite geometric series. So luckily with this one, we're not going to have to go running around to find these values because they give them to us. So we're going to do the value of the first term times 1 minus r raised to the number of terms over 1 minus r. So when I plug in, we're going to be finding 7 terms, the summation of 7 terms, which is going to be 2 times 1 minus 5 raised to the 7th over 1 minus 5. Now, numbers like this, we're not going to make you necessarily crunch and do these by hand because these numbers can get pretty big. But when you do plug in, you are going to get, I believe it's like 30,000. Yeah. 39,062. Now, looking at the third problem here. So notice, once again, your equation is going to be written in terms of y equals mx plus b in slope-intercept form. So when it's written in slope-intercept form like this, what is also nice to know is that your slope, or quote-unquote slope, is actually going to be your common difference. So I also will need to find my n value. So once again, that's going to be the top number minus the bottom number plus 1. So that means we're actually going to have 21 terms that we need to find. Now for this one, I did the top equation over here for the first one, so I'm going to do the bottom equation just to kind of show you some difference and kind of mix it up a little bit. So your equation here, so a partial sum is going to be equal to the number of terms divided by 2, and then 2 times the value of the first term plus n minus 1 times your common difference. Now, if you notice, right here, we have the explicit form of an arithmetic sequence kind of embedded in this form. The only difference is we have the n minus 2, and then we're going to multiply the first term times 2. So I'm going to plug in this information. One thing you need to know is that right here, this is the first term of the series, but notice how we're actually starting at the 5th term. So really, what's going to happen is my first term is the 5th term of the sequence. So I need to find a sub 5. So I'm going to do 1/5 times 5, then plus 2. So that's going to be 1 plus 2, which is equal to 3, which, groundbreaking. So when I plug in, we're going to find the sum of 21 terms, which is going to be 21 divided by 2, 2 times the value of the first term in this series, which will be 3, plus n minus 1, well, we have 21 terms, so we're going to subtract 1, and then your common difference, which is that 1/5. So now we're going to crunch these numbers. So 21 divided by 2, which would be 6, plus 20 times the 5th. So that's 21 divided by 2, 6 plus 4. So now I'm going to bring this up here. So 21 divided by 2, and then 6 plus 4, which is going to be 10. So that's going to be 210 divided by 2, which is going to be 105. So that would be your partial sum. Now, moving on, we're going to look down at number 4. Now, rather, with this whole row, 4, 5, and 6, notice how now we're going to be working with an infinite series. So with infinite series, now we're going to be focusing on this side over here. So starting off, notice how we are working with a geometric sequence and turning that kind of into a series. So with an infinite series, that means I'm going to be doing S sub infinity, and that's going to be equal to the value of the first term over 1 minus my common ratio. Now, when it's written in this form and you see the n minus 1, then you can just take your forms and take your values as is. So I know the very first value in my series is going to be 10, and then I also know that my common ratio is going to be just 1/2. So when I plug in, so I'm going to have 10 divided by 1 minus 1/2, which is the same as doing 10 over 1/2, which when I divide by a fraction, I'm going to multiply by the reciprocal. So that's 10 times 2 over 1, which means my infinite sum for this problem would be 20. Now looking at the next one, so for number 5 here, now we're going to have an infinite series, but it's going to be arithmetic in nature. So with this one, what's going to happen is because it's infinite arithmetic, we know it's going to diverge, which means the sum is going to be either infinity or negative infinity. Now, you have to pay attention to the common difference. Your common difference in this case is positive. So because it's positive, it's going to diverge, and the infinite sum would be positive infinity. Now, if the common difference was negative, then it would be a negative infinity. So keep in mind some problems that are going to say, find the infinite sum if it exists, or find the sum if it exists. So sometimes we might even say that the sum doesn't exist because it's infinity, but just kind of pay attention to the context of the problem. Now over here, with this one's going to be a little bit more tricky, and that's because your form over here is not how we're used to seeing it. We're used to seeing a sub 1 times r raised to the n minus 1. So because we don't have the n minus 1 up here, we're going to actually have to do a little bit more kind of finagling with our values. So what's going to happen, I'm going to rewrite my series. Excuse me, y'all. Now, this negative exponent tells me I'm actually going to find the reciprocal, so I can make it positive. So this is going to be 3 times 1 over 6 raised to the n. So in order to find my infinite sum, I need to do the value of the first term over 1 minus r. Now, we need to actually find the value of the first term, so I need to plug in 1. So a sub 1 in this case is going to be equal to 3 times 1 over 6 raised to the first power, which that is just 3 times the sixth, which is equal to 1/2. Now, my r value, we know, based on my equation I have over here in pink, is going to be equal to 1/6. So I'm going to plug this information in here. So this is going to be equal to 1/2 divided by 1 minus a sixth. So this is going to be equal to 1/2 over 5/6. So once again, when you divide by a fraction, I'm going to multiply by the reciprocal. So this is going to be 6 over 10, which is equal to 3/5. So my infinite sum here is actually equal to 3/5. Now, moving on. So with this next one, or rather, scratch that, I would say pause here, try 7 through 9 on your own. It's going to be the same kind of context that we did on the first page. So looking here, so I know that number 7 here, based on the way that it's written, this is going to be a finite geometric. So finite geometric means I'm going to be using S sub n equals the value of the first term, 1 minus r raised to the n over 1 minus r. So now I'm going to just plug in my information. So first thing I want to do is actually find my n value. So n is going to be top minus bottom plus 1. So 12 minus 5 is 7, plus 1 is going to be 8. And then the value of my first term, which I can just pull directly from the equation, is going to be a -4. And then I also know that my common ratio, in this case, is going to be 2. Now remember, I can just pull the values because we're in the form a sub 1 times r raised to the n minus 1. If your sequence or formula doesn't look like this in this form, then you will have to do some finagling like we did on number 6. Now I'm ready to plug in. So my partial sum of 8 terms is going to be -4, parentheses, 1 minus 2 raised to the 8 over 1 minus 2. So when I plug this in, give me a second, I want to definitely make sure that I do this correctly. So -4, 1 minus 2 raised to the 8th over 1 minus 2. It's going to be a decent sized number. Ah, ha. Shame on me, I did this mistake. Let's see if you can actually kind of figure out what I did wrong and see if you can determine where I should fix it. So, what I did wrong is actually right here. My a sub 1 is not -4. We're starting at the 5th term. So sorry, y'all. So actually, let's do this. All of this is going to go away, and then this is going to go away. I'm going to move you up. So sorry, y'all. So I need to find the value of the 5th term. This is what I'm going to plug in for a sub 1 since we start at the 5th term. So this is going to be a -4, parentheses, 2 raised to the 5 minus 1. So -4, 2 raised to the 4th power. So 2, 4, 8, 16. So this is -4 times 16, which is going to be a -64. There we go. It's like I knew something wasn't looking right. So now I'm going to come back over here. Let's try this again. So this is going to be the series of 8 terms added together. So the first term, since we start at the 5th term, is actually going to be -64. But the rest of this I had right. So 1 minus 2 raised to the 8th over 1 minus 2. Now let's plug in. So -64. So there we go. So -16,320. It's like, ain't no way that sum is going to be that small. Okay, now looking at number 8. So with this one, we are looking at an infinite geometric, and my r value here is going to be equal to 6. Now, because r equals 6, that also tells me that the absolute value is bigger than 1, which means this is going to diverge. So my infinite sum is actually going to be infinity. So that's all you would do for that one. Now, number 9. Now, if you haven't already, I would definitely pause here, try this one on your own, because this one's going to be similar to number 6. So this is going to be a infinite geometric. So with infinite geometric, I'm going to be doing, I keep writing A for a sequence, and it's not A. Nope, it's going to be infinite. So this is going to be the value of the first term over 1 minus r. Now, remember, we don't have that minus 1 here, so I can't just pull the 729 as my first term and the 2/3 as my r value. I actually will have to go and find the value of that first term. So the value of the first term is going to be 729, parentheses, 2/3 raised to the first value. So 729, and then multiplied by 2/3. So that means the first term is actually going to be 486. So now I can plug in. So I'm going to do 486 over 1 minus my r value, which is 2/3. Not tangent, hello. There we go. So my sum here would be 1,458. So I'm actually going to check with a summation. So I'm going to actually plug this in on a summation in the calculator. Sorry, just give me just a second, because this is how I want to check it. So especially because I don't have anyone to check with. So this is how I plug it in, just to make sure. Fingers crossed I get the same thing. Calculator's thinking, still thinking. Yay, it matches. So we're good. All right, now down here, these are going to be some kind of lower tier application questions. I would say this is some kind of run-of-the-mill questions that you could expect, but it's all going to be solving it the exact same way that we've done before. So it's really just kind of in word format. So that's kind of what's happening with 10 and 11. You're going to write it in sigma notation, and then you're going to find the actual sum. And then down here, we're going to be using those equations or the formulas that we used at the top, and we're actually going to find a specific value. So the only one I'm actually going to do over here is, let's just do 12 and 13, because 10 and 11 are kind of a recap of what we did in the first video. So looking at 12, so the first term of an infinite geometric series is 4. We want to find the common ratio if the infinite sum is 16/5. So notice the fact that we said an infinite sum. So that tells me that the infinite sum of a geometric series, so that also tells you what type of series we're looking at, is going to be the value of the first term over 1 minus r. So I know the sum is 16/5. They also tell me that the first term is 4, and they want to find the r value. So really from here, it's just going to be algebra. So you can cross multiply, so 16 times 1 minus r is equal to 5 times 4, which is going to be 20. I'm going to go ahead and divide both sides by 16, so 1 minus r is equal to 20 divided by 16. So 1 minus r is going to be equal to 5/4. So I'm going to bring this over, so 1 minus r. So my r value is actually going to be equal to 1 minus 5/4, which is going to be a negative 1/4. So that's how you would approach that one. So that's also how you would do number 13. Same idea, but notice how we give you that the ratio is actually as a decimal. So 0.2 is going to be the same as 2 over 10, which is 1/5. So just keep that in mind. So have fun, make good choices.